Hey everybody, welcome back to another fun and exciting Algebra 1 class. I know you're probably still reeling from that last lesson, long video, lots of complicated things in there. So good news, this one is going to be much shorter and hopefully something that you can kind of grasp onto and be able to take with you. So go ahead and open up your book, if you will, to page 231, page 231. And lesson 7.3 is down there on the bottom of the page. It says factoring by grouping. Sometimes you can't really factor something using kind of the methods that we've looked at so far. There's nothing common in the whole thing. It's not a trinomial. There's all kinds of things going on. So what you want to do is you want to consider the potential that you could take it and you could regroup it. Remember when we learned the associative principle in math and algebra, which means that we can regroup things, we can reassociate things. In math, addition is associative, and we can move it and we can regroup it. Okay, so since we can do that, we can factor things by regrouping them into factorable little smaller sections. All right, so what do I mean by that? Not necessarily gonna take and look through these. You can look through those if you want. I'm gonna just kind of teach it, and I want you to kind of learn this more by the feel of how to do it than an actual, okay, do this, then do this, because some of these look a little different. So I think it'll be better if we just kind of look at them and then we go from there. So x cubed plus 2x squared plus 5x plus 10. If you look at that, you might say, well, I could factor out an x. Well, no, you can't, because there is no x here. Remember, anything that you factor out has to be common in all of it, in every single one. So you might say, oh, well, I can factor out a 5. No, you can't, because 5 does not go into 2. All right, so, well, what do we do? Well, here's what you do. You take these and you regroup them. You put them into two separate problems. So we take the x cubed plus 2x squared, and then we have a plus, and then we have the 5x plus 10 over here. Okay, so two separate things. Now watch what we can do. We can actually factor something out of this one now, because we do have an x that's available here, because x is in both of them. Actually, x squared is in both of them. So what's going to come out is the x squared, and then we divide everything by x squared, sorry, and we're going to end up with inside left with an x, and then here we're going to end up with a 2, so plus 2, x plus 2. Okay, and then don't forget your plus sign. It's still hanging in there. And then this one, what happens here? We have a common 5 that can come out. So 5 comes out. If we divide everything by 5, we end up with an x plus 2. Now, this is kind of where the magic happens in these ones. Look what we ended up with. X plus 2 and x plus 2. A couple lessons ago, when we did common factoring, I said that these are now common. We can factor those out. So when we factor this out, we end up with x plus 2, and then we end up with what's left over, x squared plus 5. Each one of those are separate, okay? X plus 2, x squared plus 5. There's no other way to factor those. You can't pull out a common thing from all of them. You can't unfoil them. You can't undistribute them until you do what? Until you take them and regroup them. The only thing that's different in this lesson, the only thing that I'm teaching you here, is the regrouping part. Everything else was all factoring that you've learned in the last two lessons. In the first lesson, you learned how to pull out a common factor. You also learned how to take these binomials and pull them out. Then in the last lesson, we learned how to unfoil something. You learned how to undistribute, right? So it's all there. We just have to get them into a format that we can actually use. All right, look back into your book there, and you'll see right here in on page 231 in this little section here off to the right hand side, you'll see where the book does the exact same thing that I did. They pull out the x squared, they pull out the 5, and then they mash those together. These two red ones become one. Why does two things become one thing? Because they're common. You pull them outside, and now you, instead of adding them together, look what you're doing. You're multiplying. The addition sign goes away right here, and it becomes a multiplication problem. That's why two can become one. That's why you can, if you have the same thing, you can pull it outside and you can make it multiplied by that, and it ends up working out. So just math principles there that you have to trust. All right, go ahead and turn the page. We are now on page 232, and we're just going to do this one. Here's another factor by grouping. So let's go ahead and work through this one. So we have 6n cubed minus 4n squared plus 9n minus 6. And you might say, oh, look, I can do 3 by these ones. But guess what? You can't do 3 by that one. You might say, oh, look, I have n's that I can pull out. No, there is no n over here with the 6. So we're kind of stuck. And we're stuck until we do what? Until we group these things. So we're going to group them again, and we're just going to start pulling stuff out. What do I pull out of here? What does a 6 and a 4 have in common? What's the common factor? Yep, it's a 2. And then the n and the n cubed and the n squared has an n squared in common. And again, if you don't remember how to do that, you have to go back and watch the other video. I don't have the time in this video to show you again how to do that. This is something that we're building on a skill that we've already taught. And so you can always go back and watch that previous video if you're struggling. Now what we want to do is we want to divide everything by this 2n squared. And that's going to come out to a 3 up top, and that's going to come out to an n. So we have a 3n, and then we have a minus, and then we have this is going to be a 2, and this is going to be just a 2 because the n squareds cancel, so minus 2. Okay, and then and remember, this is a 2n squared that came out. We undistributed that one. There's a plus sign in there. Don't forget your plus sign. And then we're going to do the same thing. What's common here? What's common here is a 3. I'll put it over on this side, is a 3. That's it. There's no common n, so it's just the 3. So we're going to divide everything by 3. So that 3 is what's distributed, to go back into that, or what we're dividing by. So that 3 goes here. Then in parentheses, that becomes a 3n. So 3n here. There's your minus sign, and then we end up with a 2 here. Well, guess what happened? 3n minus 2, 3n minus 2. So what we can do with that is that's common. It comes out. So 3n minus 2 comes out, and then everything that we have left over inside. 2n squared plus 3 is our other piece to that. All right, so here we go. This one is tricky right here, and I'll show you why. This negative sign makes it tricky. So as soon as we start kind of separating these, the tendency is going to be to go like this and leave that negative sign out front. This is actually a minus 3x, so we have to put the minus 3 inside, and this actually becomes a plus. And again, a little bit tricky, a little bit technical. If you don't do that, you're going to mess up the whole thing, though. So you have to remember, what does this mean? Okay, let's go back to this. This means x cubed plus a negative x squared plus a negative 3x plus a positive 3. So it's important to remember what we're looking at here, and these signs go with this. So those signs are connected. These signs are connected. This sign is connected. So what is this going to look like? This is going to look like x cubed minus x squared plus, and again, that negative goes with this, plus 3. Okay? This one is really tricky, and it's really complicated, but you just have to remember to do that. We're also going to have to do something else here in a minute to get it to work out. But for now, that's the way that you separate those. That's the way that you group those. Because remember, subtraction is not associative. We can't just move subtraction around. We have to make sure that we're using addition. So the way that you use addition is that you assign the negative sign to that 3x and just kind of move it over and we add them or we combine them. All right, now what? What comes out of here? Well, our x squared comes out of there, and then we divide everything else by x squared, and then you're going to get x, well, this would be x to the 1 or just x. There's a minus sign, and then this cancels, and so it cancels. When something cancels, it cancels to a 1, and then we get plus, and then what comes out of this is going to be a 3, and so we get our 3, and it's a positive 3, and so 3 comes out, and we're left with negative x plus 3, or excuse me, plus 1. There we go. How do we do that? We divide everything by 3, okay? Now, if you notice this is why I said it gets a little tricky. This does not match this. And the way that we resolve that is we put a negative 1 through this. And when we do that, this becomes a positive x, and that becomes a negative 1. And we can do that, and everything's fine. You're just going to, again, you're going to have to trust me that we can do that. We can multiply a negative 1 through it. As long as we change all the signs in the parentheses, it works out. So when we do that, we end up with this x minus 1. That's important because those match. Those go together. Okay, so what does this look like? It looks like x squared plus 3. That's the kind of the first factor here. And then the x minus 1 is the second factor. Okay, and that would be our solution. All right, let's do one more and then we'll be done with this. All right, so once we kind of get this one going, this one, again, didn't have a negative sign, but you might say, well, what did you do? Because now we can't do anything with this. Look, the 2 and the 5, there's no common factor there. Now look over here. I mean, I could take out an x from this, but now I have an 8 and a 20. What do we want to do here? Here's what we want to do. We want to rearrange it with the things that match up, that make sense to kind of do our division by. What are those? Well, if we put the negative 20x squared with the negative 5, then we can pull a 5 out of both of those. If we put the 8x cubed and the positive 2x together, we can pull out a 2x from those. So we want to rearrange everything here. Remember, it's associative. We can rearrange it as long as we're taking the sign with it. So here's what that's going to look like. 8x cubed plus 2x. Because you're rearranging it so that it matches, so that we can get things to come outside. If we don't, then nothing comes out. We can't factor it. And then we would have so that would kind of be part. And then we would have, remember what I said about the positive, and then it's plus. And this is going to be negative 20x squared minus 5. All right, so what we want to do now is make sure that we pull out our 2x, because 2 goes into 8 and 2 goes into 2. X goes into x and x goes into x cubed, so we're pulling out a 2x. Then we're going to divide everything by 2x. And we're going to end up with our 2x. And then, so that's going to cancel out to a 4. That's going to cancel out to an x squared, so 4x squared. Then we have our plus sign, and then this is going to cancel to a 1. This is going to cancel to a 1. 1 times 1 equals 1. And then plus. And then what comes out of here? Well, you say a 5 comes out. No, a negative 5 comes out. So it'd be a negative 5, negative 5. We're going to divide everything by negative 5. And this is going to end up negative 5, negative, negative gives us a positive. So that's going to give us a 4x squared. And then minus minus, another positive, and 5 divided by 5 is 1. So that basically this is our answer, but we have kind of something weird going on here. We have a positive and a negative. Whenever you have a positive and negative next to each other, that just ends up being a negative. Okay, so the negative kind of wins out right there. Notice we can take this. This is common. We can factor it out. 4x squared plus 1. And then what's left over is this right here. So 2x minus 5. And that would be the way that you solve that one. So lots going on there, negative signs. Man, if you can keep this work as neat as possible in your notebook, that's going to really help you because you're going to be able to see, you're going to go back, you're going to be able to check it, you're going to see, okay, where'd my negative sign go? And don't feel bad when you miss one of these. Don't feel bad when you forget something. Just make a mental note, okay, next time, yeah, that's right, I got to go back and do that. You're going to miss some of these. You're going to put a negative sign where there's not supposed to be a negative sign. If you can really work on the process though, you will end up doing very well in on your assignments, on your quizzes and tests, because you're going to be able to know that, yeah, you might miss a few little points here and there, but if you get the process down, focus on the process. Don't focus on, beating yourself up over a little mistake here and there, but work hard on making sure that you know kind of how that works and how to kind of separate them, how to pull out the common factor, how to divide it out, all that good stuff. All right. That's all I've got for you. Hope you learned something there. We'll see you later. Have a good one. Bye bye.